let's begin with the following. So we've been talking about technology. Let's talk a little bit about yes.
There's a
New driver upgrade. Install the driver. Oh, this is for the stupid. This is for the. Yeah, that's not on my computer. That's on the stupid. Who's heard of the trolley problem? Tell us what it is. Yeah. Yep. Okay, so just to put a visual on that, here it is. Right? Anybody recalls this? So a person is given a choice between switching the track, killing one person, or letting 5 people die. What's the other situation in this case? I don't know about that variation, but the variation I present is the following. So instead of doing a switch, you have the opportunity of pushing a person over this walkway onto the tracks, killing that person, but saving those 5 people. Right? So this is a little head game that psychologists play with people to see what their answers will be. So what typically you find is that people have no problem doing this. Right? A lot of them will say, "Oh yeah, I'm going to switch the track. I'll kill one person, but save those 5 people." However, they won't do this. Right? Why is that relevant? Because of several technical developments recently. Okay. One is a proliferation of drones in warfare. So if you think about it, using drones to basically deliver destruction is fairly easy if it's just a switch. But if you were to actually get into battle, that's a different story. You know, most people will say, "Well, I don't want to get into that." Okay. But that is something that actually is an issue that there is no solution to it. I'm just presenting it to you because as technology comes along, these are the kinds of questions that arise. Without technology, some of these problems really are more academic than anything else. With regard to self-driving cars, the questions becomes, as some of you may have heard, is like, what happens when you find yourself, or the self-driving car finds itself in a situation where it can either kill the passenger or kill the school bus full of kids? What's the correct way of doing that? How is a programmer supposed to tell the self-driving car what to do in that situation? Again, there are no straight answers for this, but these are the kinds of conundrums that people run into with new technologies. Okay? And that's one thing that I want a lot of you to sort of think about, because you may be faced with some of these kinds of issues as to whether or not a technology will be good for society or bad. And being good or bad sometimes depends on which side of the equation you're on. Okay, Thanksgiving Day is bad for turkeys, but good for people, and it's always from the perspective of who's winning and who's losing. So just to put that into perspective. Any questions about this? We'll revisit little snippets of these types of issues so that we don't just deal with technology, but also to have you guys think about some of the conundrums that arise. Partly because a lot of the things that we have in society in terms of laws are antiquated, and they have not caught up to some of the technologies that we're actually living with now. So in that regard, what I want to do is sort of review some of the reading assignments and the podcast, just to give you a sense of what to expect for these if you haven't done these already. So as far as the readings are concerned, we have a book, Weapons of Math Destruction, which is the big book, and then the Math Conan Attack. If you haven't read that yet, please do so. In terms of what happened with the Equifax fiasco recently, this happened several years ago, but the same thing can happen if that kind of information is accessed by people who shouldn't have access to that. So reading number 2 is just strong passwords. Just a little tidbit on how you can come up with some passwords that can be easily remembered. Reading number 3. So we've used a lot of things that Google has done, has presented or made available. One thing that you should keep in mind is that a lot of these things that are developed at Google are not necessarily from Google. Many of the things that we're using, Google Docs in particular, actually started out as a company called Writely.com. They bought out that company, used the technology, and rebranded it as Google, right? As a Google Docs. Same is true with Google Maps and Google Earth. Those were actually companies that existed outside of Google, but Google saw the potential of that, and what they did is bought those companies to rebrand the products as their own. Okay, Google and many of the companies will do what's known as an acquire. It's ACQHIRE. The idea behind that is that they will acquire a company, not so much for the product, but for the engineers, so that they can use them in whatever projects they want them to work on. So those are some of the things that happen. But Writely is one of those classic cases where Google actually bought a company to show as their own. So online reputation rules, something just to keep in mind as you go through and work on your project number 1. What are the things that you should do or not do? In some cases, some of the things that you're not supposed to do is probably a little too late, because Facebook already has that information. And even if you do delete it, I want you to know that there are companies that actually go around Facebook and other websites and actually snapshot those different websites. So even though you believe you may have deleted something, somebody's actually probably scraped it up and stored it in their database. Yes?
If we're concerned about things like Facebook, sites like Facebook, why is that the data you can access from that any different from the data you can access from something like Swarm, which is like location-based technology, and it has people check in photos?
That is correct, yes. So what is the question?
So what makes that different?
What makes it different? It all depends on what the company's trying to do with that information. So with Swarm, if you ask yourself what's their business model, their business model is to basically try to get better geographic information. So every time you check in, they can see it's like, oh well, okay, this is a particular location, which is probably a classroom, and that's the kind of analytics that they can start doing. Whether or not how they use that is again one of those questions that we really don't know. Some companies just aren't very open about what they're going to do with that, and that's why you have that long terms of service, which we'll talk a little bit about. Is that you're basically saying, if you don't read those things, you're basically saying, go ahead and use my data, even though I'm using free service, because I am the product. Just because something's free, there has to be a cost somewhere, and the cost is typically your behavior. And based on that, on your behavior, they can sell that information to other people who can then make predictions as to when you're going to buy that makeup or something like that. So those are that's what issues. Now, is that good or bad? I don't know. But it's something to think about. You know, what is Facebook actually doing with all your information? Does that answer? Sort of. It doesn't answer it. A lot of these things that we present in some of these readings and podcasts really have no straightforward answer. But I think it's important for you to try to understand that in the event that you find yourself in a situation where you can direct policy. As frankly, all the computer science people won't be doing that. They'll be going to Microsoft and Google and developing more algorithms. So we need people who know about the technology and guide those kinds of policies. Crow backup overview. I want you to know that, read that and know the rules of backing up. Okay. And the last reading before the midterm is the FAA regulations with regard to drones. Again, another technology that would not be possible without computations and computers. So it's a myriad of a mishmash of different technologies, but hopefully it'll give you a sense of where some of these things are applied. Right. Let's look at the podcasts now. And again, I'm sort of presenting this now so that you guys can catch up on this for the upcoming break. When is break? A couple of weeks. So next week. Is it next week? There you go. So you can't say I didn't know about it. Again, passwords. It's just too important. So yet another lecture on passwords, on what you can do. Podcast number 2 is the LastPass video. Again, related to passwords. If this gets a little too long for you, you can skip it. The only thing I want people to get out of this video is the fact that somebody in the security industry has sort of given the green light for LastPass to be used. He basically says, yeah, they're good. You can use it as long as you have what's the most important thing with LastPass? What's that? A strong master password, okay? If that's weak, then it doesn't matter. Podcast number 3. It's a little dated, but I think it's good to know about what some people do with regard to patents. So when patents attack is essentially a podcast describing what some companies actually did with regard to some patents and how they stifled innovation because of the fact that some patents, or patent trolls, or better known or legally known as non-practicing entities, actually did a lot of litigation for people who developed something only to sue them because they were holding a patent of an invention that somebody else has sort of reinvented. And that actually is something that still happens today, not as much as it used to, but that is something that can happen with a lot of companies. These patent trolls or non-practicing entities will basically sit on a patent and then when somebody develops something, they'll say, oh, you got to pay us money. Okay? And if you don't pay us money, we're going to bring you to court. And typically when these people go to court, they go out of business because legal fees can basically bankrupt a company. But the practice of patent trolls is something that still occurs. There has been a little bit of a movement in terms of the government trying to take care of that. And there'll be a second podcast, a follow-up to this podcast with regard to patents. Okay. Podcast number 4 is LibreOffice, which is actually an updated podcast, fairly recent, just to give you a sense of what open source projects, how how they can evolve. LibreOffice has been around for a while, and also it'll tell you how some open source projects actually diverge in much the same way that you have different animals going through different speciations. The same thing happened with software, where you have a software that comes from a particular lineage, only to find that it forks off into two different types of software. So they talk about that a little bit. Some of it is based on politics. Some people don't get along when they're working on an open source project, and they decide to split the project. So that's actually happened with LibreOffice. Some of you may have heard of OpenOffice. That's the other development strategy, the other development group that came out of that. But again, I want people to get a sense of open source projects and how they can be both useful, but at the same time can cause a lot of issues. Podcast number 5 is the Worm Podcast, which Internet Worm. It talks about the Conqueror virus, which is still around. They also introduced the concepts of distributed denial of service attacks, which is actually something that happens quite frequently. Most of us don't hear about it until they become successful, and all of a sudden you can't get to your websites that you frequent. So this is just an introduction to some of the issues with regard to cybersecurity and cyber warfare that is happening as we speak. Yes.
For the podcast, if they have transcripts available, can we read the transcripts?
Yes, you can read the transcripts.
Or, like, the information will be okay?
Yeah,
for that?
yeah. It's whatever is. I tend to, again, I like podcasts just because I can be doing the dishes and listening to something, as opposed to I can't really drive while I'm reading the transcripts because I actually get sick in cars. So, but yes, that if you're, by all means, if you have the access to transcript, you can more or less do that. So. And because this is my bias, I want you to watch both the Geospatial Revolution Episode 1 and Geospatial Revolution Episode 2. So what this is, these two videos do, is sort of give you a sense of what it means to be in a geospatially enabled world. For next Tuesday, we will have Blair Tinker come in and give you a lecture on geographic information systems. So I call it a mandatory attendance. He'll be the guest lecturer, and he'll talk about GIS and some of the things that you can do with it, and also introduce to you that he does teach a class in geographic information systems. It's a very, I don't want to say lucrative, but if you know something about GIS, there's a good chance that you can learn it on your own and actually make a fairly decent living in working with it. And it also doesn't really matter what your field is. If you know how to enable your data with geographic information, it just makes analysis so much easier. And he will actually go over an example back in the 1850s of how geographic information actually came up with a conclusion that basically made sense. I mean, a lot of the things that was analyzed by this person fit together in such a way that it's almost hard to refute the conclusions that he came with. So there's two Geospatial Revolution video podcasts. There's another two that we'll cover next after the midterm, but I just want to make sure that everybody's aware that these exist so that you can get going with reading these and consuming it and trying to digest some of the information. Again, I'm not looking for specific details, right? I just want you to sort of listen to it and ask yourself, one, why do I need to know about this? Okay. And that's a question that you should always ask yourself. Why is this important? And two, I can't remember what number 2 was. It's just been one of those days. Why am I having you watch these things? And two, how does it matter to me? Why is this important to me? And that sometimes is not always clear, but at least those are the 2 questions you should be asking.
What are the 2 questions?
Why did I assign you to listen or read to this? There's a reason for me for assigning these things, and what you should try to do is ask yourself, why is this important? And 2 is, how does this relate to my field, your field of study?
Oh, it's more than 2 questions.
Wow. More than 2 questions. 5. Well, okay, give me the 5 questions. Yes. No. Why? Why? Never mind. All right. All right. So we did human readable, basic. Let's talk about vector graphics. So in the previous lecture, we talked about images. Anybody have any questions with regard to images? So the image is basically a set of pixels. Let me just start this up. And there's another form of data that some of you will use in terms of presentations. One of them is images. So images are basically pixels. They're sometimes called rasters. And there's another data form called scalable vector graphics, or more commonly known as scalable vector graphics. What's the difference? One is just a gridded set of images, while the other one is actually a description of a shape. So what does that mean? Well, most of you have seen images, as we've done in the previous lecture, where we actually created an image by hand, displayed it, and we saw that we present picture elements individually. So if you have a raster format, such as JPEG, GIF, and PNG, you are essentially creating a grid and then putting different values in each of those pixels. Right? That has its advantages. The advantage is that you can put almost anything, all the different combinations, into the different grids. And that's what happens when your camera takes a picture. It basically measures the light from different grid points in the scene and stores that. In some applications, however, you really don't want that. You want what's known as a vector graphic. So SVG is a vector graphic. And what that basically is, it's a mathematical representation of a shape, right? So a lot of shapes that you would use, such as arrows, fonts, letters, can be described mathematically. The advantage of that is that it doesn't matter what kind of resolution you print something at, it will always be at the highest quality. That is not true with a raster image. You don't have mathematical descriptions for pictures. Okay? It's not like you can come up with an equation to say this equation represents a picture of my parents. That doesn't exist. However, you can come up with an equation for certain types of shapes. And we'll actually look at what some of this looks like. So if you see a scalable vector graphic on the web, for instance, this is what it would look like under the hood. So if you look at this, what does this look like? Yes?
Isn't that like HTML and CSS kind of stuff?
Well, that's actually XML, right? very similar. I mean, it is XML. And what this basically says is that by describing it with these parameters, the computer can render that lime green rectangle, right? Yes?
This may be a little off topic, but what is the biggest difference between HTML and XML?
What's the difference? HTML is not as rigorous as XML. If you recall, what's that? No, so HTML will allow you to do something like this. Okay. The problem with that is that it's as if you're created an equation that has no parentheses, that has no closing parentheses, and it's very hard to then start to figure out, like, oh, okay, well, how do I calculate this? So XML is nothing more than HTML, but stricter. And in fact, you'll hear XHTML as a terminology. And what XHTML basically says is that it's very strict. So what I talked about before about having tags and slash tags is enforced, right? So that's the main difference for that. Yeah, HTML was sort of this when it was developed. It was sort of a I hate to use the word, but a kind of a bastardized form of XML. It was very kind of loosey-goosey in terms of the grammar or the structure, and it just let it go. So that's what the scalable vector graphics looks like. Right? It's not an actual image, but it's a set of characteristics which can be interpreted by whatever web browser you have. Right? So same thing with fonts. You should typically will see fonts expressed in this manner. So if you recall, when we started playing around with LibreOffice and we started saving out Hello World in different formats. Some of those you could read, similar to this. You have all the descriptions as to color, right, height, fill. So that information is stored there. So here's another example. Again, very similar. You basically have all these different tags here that tell you what the properties are. So that's why scalable vector graphics can be so precise when you print it out or use it in a PowerPoint presentation. Okay, what you want to do is, if at all possible, use scalable vector graphics when you put it into your presentations, so that you don't get the pixelated graphic elements in there. So yes. It's typically, it depends on the site. Some sites are XHTML compliant. Other sites are not. Okay, it all depends. There are some sites that still use Flash, Adobe Flash, and there are some sites that don't. So there really is no enforcement in some of the websites. Would have been nice if they just said, let's do everything XHTML. There's a lot of the things that would not be as problematic as they are now. But it's evolving. Everything's evolving. So I don't know if that answers your question. Again, so one thing that I want to point out also is, some of you asked, well, hexadecimal. Why do we know about that? Well, look at what you're seeing here. These are actual hexadecimal values, right? They represent certain colors or certain properties. So when you actually look at something and you see these hexadecimal values, they have meaning behind that. That's one of the reasons why I said, you should know different bases, because it's actually very much easier to be able to just put a value there, not a value, but a set of letters there instead of a whole bunch of numbers. So. Yeah. I'll present the slide. But again, scalable vector graphics, bottom line, if at all possible, use them. And know that they're not really images. but descriptions of shapes and can be modified based on modifying these tags. So I just realized we didn't go back to the original question that I ended with last time. And let's actually jump to that. This one. Okay. Star for greater than HR slash. What the heck does that mean? Okay. And what I showed before is that if we put that pattern in here and display the image as a bi-level image, this is the pattern we see. And you might ask yourself, well, I don't see that. I don't see how that can present that kind of image, this pattern. And then I also, I don't think I showed it, but if I actually use that same pattern and present it as a grade value image, I get this image. If I actually run my cursor over here and look at the values of this, this is 42, 52, 62, 72, 82, 92. Okay. So how can this pattern show me two different types of images? And there is a reason for that. And what we can do is actually go back and let's look at Excel. You're wondering, what? Excel? How in the world are we going to use Excel to do this? Well, not Excel, but it's, Google Spreadsheets. Okay. Start a new spreadsheet. Decimal value. 42, 52, we went all the way up to 92, all right? Everybody kind of saw that. Well, what was one of the first functions that we actually can't remember who asked it. Was it you who asked the decimal to binary? Yeah, okay, so if we do this, decimal, binary, we want to take that number and represent it as 8 digits. Hit return. And let's apply that down. Now let's go back and look at the image that I presented. Okay, 0, 0, 1, 0, 1, 0, 1, 0, which means it should be 0, 0, 1, 0, 1, 0, 1, 0, 0, 0. Oh, no, actually for the first 8, 0, 0, 1, 0, 1, 0. That's what we got there. Let's take the next pixel, or the next 8 digits. It should be the same pattern that we have here. Right. And so on. So you can actually go through this, all this 0 and 1 patterns here, and see that it actually matches what we have here on this image. Because what this information is being interpreted in binary form. Everybody see that? It's being interpreted in binary form. So that pattern that you have here will be the same as what you see up there. Yes?
What's the reason for doing 8?
8. Oh, the 8 is the number of digits. If I didn't do that, in fact, let's actually show you. It becomes harder to interpret this. If I actually did that and I just said decimal to binary without that 8, it becomes harder to. It doesn't put the number of. It doesn't divide it by 8. In other words, it doesn't put the leading zeros here. So what this is saying is that I want it to be all 8 bits of information. Also, I can actually take these numbers and actually, if you recall, the ASCII table. Let's look at number 42 in decimal. What's that? It's the asterisk. 52. Number 4. 62. Greater than 72. H. 82. R. And 92 slash. And we can actually do that also in the spreadsheet where I can say ASCII character. I can say equals right?
Why does this spreadsheet know that? How does it know that?
Because it's been defined. It's been defined by the ASCII table. This was a definition that people back when computers were being developed that they standardized on this convention. Okay. In much the same way that languages, we have to standardize on what we mean, what letters we use. Okay. Same thing happened with computers. We have to somehow standardize the different characters that we're talking about. And the characters can only be represented by 1s and 0s. So we basically say, well, okay, if it's just 1s and 0s, what do those patterns of 1s and 0s match? Okay. So what we're doing here is we're saying, if you see a pattern that a binary pattern that matches the decimal value 43, we know that that will be associated with an asterisk. So this is how images are represented in binary form. So what we showed here is the fact that you have images that have the same information but different interpretations. It takes a little bit of getting used to that, but that's actually how computers work. They work in binary form, and how you interpret that pattern of binary forms, it's really up to the context. In much the same way that we had the word row have different meanings depending on what context you're using that word in. Okay? The same thing can be said with data to a computer. You know, it can be either a command, it can be letters, or in this case, it can be pixels in an image. So it all depends on the context of how you interpret that information. Right. So let's jump very quickly into an example. So some of the things that you'll be doing with in either Photoshop or GIMP is playing with images, and just want to show you some of the more practical aspects of processing images. So we talked about images here. Let's actually do something practical with it. So we'll go into GIMP. Okay. And I'm just going to upload a picture that is not the best picture, but that's part of the fun of image processing, is that you take pictures that are typically not great and somehow extract information from it. So let's actually open it. And what did I call it? Oh, backlit. All right. So let's rotate. Lights a little bit. So sort of have a sense now of what images are. It's nothing more than just values associated with a given picture element. Okay. Now, one of the things that you can, one of the statistics that images often are calculated with image. So one of the things that is often calculated with regard to images is what's known as a histogram. A histogram basically says, I have a pixel, it has a certain value, how many times does that pixel occur? So the analog that I give to people, and it's something that will actually calculate, is how many times does a word occur in a book? So what you have there, if you can do that calculation, that is known as a histogram. How often does a given category occur in a whatever data set? Well, the same thing can be said with images. You can count each pixel and ask yourself, how many times does it occur? Most images are ranged from 0 to 155. Okay, so this is the histogram. What are we seeing here? We're seeing a lot of dark pixels. And we're seeing some bright pixels. Now, what you can do with this histogram is you can adjust the distribution of this. Right? You can apply certain types of properties to that. Now, what I just said might not make a lot of sense, but if I actually apply that, so you watch the histogram and watch this picture. Now, many of you probably can't see anything in the foreground here, but if I actually do what's known as a histogram equalization, that was just the help. Enhance, it's under Tools, Color Enhance, okay. What it's doing is it's actually taking this distribution and pushing it out so that it tries to apply more of the pixels in a region that you can actually see. Right? So what you just saw there is it took that histogram and pushed everything, spread it out into the areas where you have more mid-range values. And now you can actually look at the image and you can see that the area which was pretty dark is now a lot more visible. Right? It actually made this a lot brighter, but sometimes you have to sacrifice processing some parts of the image with the other ones where you want to find some information. So the other thing also I want to point out is the fact that you can actually interrogate each of these points. So I can actually say, this is something that I never remember, so that's why I have to look under Help, under Dialog Boxes. and I can actually run the cursor over given regions. So let's take a look at, let's actually unenhance it. We'll bring it back to the previous. Undo the equalize. And I can now run and see what the values are for the different locations. So let's go to this reddish spot here. And one thing you'll notice is that you have a lot of red, a little bit of green, and not so much blue. And you also have the hexadecimal equivalent associated with it on wherever you run that pixel. If I drive my cursor over to this area, you'll see that the red, green, and blue values are very small. And likewise, the hexadecimal values will reflect that also. If I move it over to the yellow, yellow should show a lot of red and green, but very little blue. And that's exactly what we see here. Red, so this is actually yellow. And one thing you'll notice also, again, is that the hexadecimal F, they have high values for that. So that's where some of the image processing occurs with that. I'm not an artist, but some of the things that you can do with GIMP and Photoshop, and the ones that I typically use is what's known as using the magic wand or something like that, which allows you to select, and some people do this by hand, and I'm not very good at it, but the one particular one is what's known as in GIMP, it's called fuzzy select. And all it simply does is it allows you to select a given region, and it tries to grow an area where you might want to make some processing. So in this case, it actually selected some of the black regions. Actually, let's undo that and see if we can select something a little simpler. Okay, I can say I want to select the yellow part of this, and as you can see, it selected. So it works really well for areas that are very uniform. I can cut that out and put it in other places, so I can actually edit, cut that out, and there you go. So those are the kinds of edits that you can do. There is the concept of layers with GIMP. So as you cut out different pieces of elements from an image, you can create certain layers, and at the very end, you can actually collapse all those layers to come up with an image. So if you're into like taking the heads off of one person and then pasting it on another person's body, these are the kinds of tools that you'll be using to do that. So any questions with GIMP? Again, I'm not an artist. I tend to work more on scientific data. And what I showed you with regard to being able to see things in areas where you can't see anything is some of the techniques that I use in image processing. Okay, we deal with a lot of situations where you can't see something in the shadows, but using a little bit of these techniques, you can actually do that. And there's actually a professor here in the Department of English who does these kinds of techniques on ancient documents that are deteriorating. And his goal is to be able to, for people to image those documents so that scholars can read them. And some of the techniques that are used in GIMP and in other programs allow you to extract that information which you normally would not be able to see. Any questions with that? So ASCII table, basic vector graphics. So the two things in preparation for Blair's lecture, know the difference between raster data sets and the difference between vector data sets. Those are two things that he'll be emphasizing in GIS. The raster data set and the vector data set. Other questions? Yes.
What's the difference?
So the vector data set is the one that's mathematically defined. So if you recall, let's go back here. Remember the slide. Okay. If it's raster, it's pixelated. If it's vector, it's mathematically defined. And there's a reason why he'll talk about those two types of data, because geographic information systems will either use raster for images, for satellite images, for aerial images, but then you want to show where the roads are and annotate them with text. You would use vector information to do that. Okay. Legitimate question. It's a concept that you don't always run into. But those are the two things that I want you to be able to distinguish between raster data sets and vector data sets.
So is vector typically used for like Google Maps?
It can be. Typically, so if you're familiar with Creative Cloud, Illustrator works in vector forms. Photoshop is raster. So if that helps you. Illustrator, when people do drawings or graphic designs, those are typically vector data sets. And photographs will be raster data sets. Okay. Yeah, you will have actually one GIMP and one Inkscape is the open source version of Illustrator. Okay. We'll see you on Tuesday. Please come to that. It's a very interesting lecture, and I think you'll find it helpful.
Professor,
Yes.
so in terms